Welcome back everyone. In today's devlog I'm going to show you how I optimize my mobile games performance by 100 times. I went from 1 FPS to 160 FPS by making key changes to both my code and Unity settings. If you're a game dev or just curious how games run smoothly with so many enemies on screen, stick around and I've got some powerful insights and tips to share. Now let's dive in. I started with code optimizations. One of the biggest issues was how my towers targeted enemies. Every few frames, towers would loop through all the enemies in their range to find the first target. Sounds simple, right? Well, here is where it all went wrong. In the old code, for every enemy, I was using get components to retrieve their movement script multiple times. And if you know Unity, you know that get component is expensive, especially when you're doing it hundreds of times per frame. On map 25 with tons of enemies, my performance tanked. So I created an enemy data cache. Now when an enemy enters the tower's range, I grab their health and movement components. I do it only once and store them. With this cached data, towers can find their targets without constantly calling get component. This alone gave me a massive performance boost while preserving all the old functionality. I thought I could improve this even further by using multithreading. Unfortunately, Unity doesn't natively support C# multithreading the way you would expect. I would have to rewrite large chunks of my code using burst or job system, but that could break the game and might actually perform worse with fewer enemies on the screen. So I decided to stick with the optimized loop. Next, I optimized the enemy movement script. Previously, I updated the movement direction every frame, even when the enemy didn't need to turn. Now I only update the direction when a turn is required, which reduces calculations per frame significantly. But even after all these changes, I was still seeing dips to 1 frame per second. Something wasn't right. That's when I turned to Unity's profiler. If you've never used the profiler, you can open it with the shortcut Ctrl+7 or by going to Window, Analysis and Profiler. I'm still new to using it, but wow, what a game changer. It showed me exactly where my performance was tanking. The blue graph represents my code, but it was the orange graph representing physics that caught my attention. I was shocked because I didn't think my game used much physics. Sure, I have simple colliders, triggers on enemies, towers and bullets, but nothing too complex. Or so I thought. The problem only became obvious when I tested a level with hundreds of enemies spawning rapidly. The profiler showed that physics calculations were consuming a whopping 230 milliseconds per frame, completely unacceptable. To run the game at 60 FPS, 1 frame can only take 16 milliseconds. After digging through the hierarchy, I found something called solve continuous. I remembered seeing a similar setting in the rigid body component. Sure enough, my enemy prefabs had collision detection set to continuous. Since I wasn't using complex collisions, I switched it to discrete to see what would happen. The difference was night and day. Previously, wave 18 would slash the performance drastically. Now in the profiler, the orange graph was tiny, even on wave 19 and 20. Physics time dropped from 230 milliseconds to just 4 milliseconds. A huge improvement. With physics under control, I checked the profiler again. This time I noticed the IK manager was taking a few milliseconds. It handles enemy animations, and while I could switch to sprite sheet animations for better performance, that would require heavy textures and a ton of rework. For now, I'm satisfied with leaving it as it is, since it only costs 1 to 2 milliseconds in the worst case scenario with hundreds of animations playing at the same time. At this point, players with high refresh displays can enjoy 120 FPS gameplay most of the time. Battery life is better for all players, and lower-end devices can finally handle map 25 without turning into a slideshow. After all these optimizations, I achieved 100x performance boost, going from 1 FPS to 160 FPS. While the blue graph still shows room for improvement, I will save further optimizations for a future update. Performance improvements like these make a huge difference, especially for mobile games, but they don't happen overnight. It took a mix of code fixes, profiling, and some trial and error to get here. Let me know if you found this devlog helpful. Do you have any performance tips or tricks that worked for your projects? Drop them in the comments. Thank you for watching, and I will see you next time.